building is some model buildings made from simple materials such as surgical rubber and wood dowels to show how buildings react to shaking experienced during earthquakes and how different construction styles will either help a building or hinder a building during an earthquake. So we start with such materials as square wooden dowels, surgical rubber tubing, Gorilla Glue, snap buttons, which we can snap on and off, X-Acto knife for cutting, straight edges for drawing lines, a drill and a saw, which are not shown here. We start with a wooden dowel. We measure off with a ruler a set distance, 4 inches, to show how long the dowel should be. We cut it, come up with columns and beams like this. We have surgical rubber, which we cut to set lengths and at angles using an X-Acto knife. We cut several pieces at a length of 5/8 inches. We cut many pieces at 1 inch lengths, which we then cut at 45-degree angles using the X-Acto knife to form the corners. We glue these together using the Gorilla Glue to make these 3-way joints, which will then act as the corners of the building. We also take some wooden dowel and we measure out a distance of 1 5/16 inches, and using a 45-degree angle, we can draw lines on the dowel, which will then, when cut, will form trapezoids, 45-degree angles, which can then be inserted as braces in the sides of the building as seen here. Using these trapezoid pieces, we drill a small hole into the end using a drill so that the buttons can set into the dowels and be strong. We glue these buttons into these holes to form pieces like this. Using all these elements, we glue them all together. We form a rudimentary building as seen here. So now we have an example with no supports in it, just a simple frame building. We then take the buttons and add the base elements. We glue them onto the supports, onto the columns and beams of the building at a distance set by the length of these pieces, where we can then add these trapezoidal elements in to form structural support for the buildings. Okay, we can snap these in rather quickly. Just form supports for the building. These supports act as either a reinforced concrete column beam connection or a steel I-beam with a weld would act. They reinforce the corners, which are most susceptible to damage during an earthquake. And since the corners are also what holds the building up, if they are damaged during an earthquake, the building is more likely to collapse. By adding these trapezoids, we form triangular elements in the building. As you can see, it's triangular shaped. And these these distribute load throughout the building and strengthen it. As we can see, when the building has been strengthened, when you attempt to shake it, there is really no shaking at all. If we pop all these supports back out quickly and easily, you can see that the building is now very weak. This is very similar to buildings that are used with tuck-under parking or stores in the bottom floors. Buildings are built like this all throughout the United States and are still built like this in third world countries. So even though the upper floor is stiff and strong, the lower floor is no longer strong at all. If we take the building with no supports in it, we can see that it's susceptible to all sorts of shaking, shearing, front and back. It can be crushed, it can be molded very easily, it can be squeezed in all ways. It can be shaken, it can be disformed rotationally. It's susceptible to all sorts of damage. Whereas if you have the supports in the building, we see when we put the supports back into the building, the building is not only stable when it comes to shaking, but it is also stable when it comes to structural loading and deforming in other forms as well. So, shaking both together. You can see, compared to the other building, there really is no comparison. You can also see that this building is susceptible to shaking, is susceptible to certain styles of shaking. If you shake it quickly, with low amplitudes, there really isn't that much deformation. But when you do large amplitude shakes at a certain frequency, then the building is most susceptible to shaking.